All right, so we'll begin by going over the homework. So for homework, I asked you to find some reference angles. So I gave you 4 separate problems, right? So the first step you got to do for each one is figure out what quadrant it's in. And then once you figure out the quadrant, you can figure out what rule we use for our reference angle. Okay, remember we had 3 situations. If it's in the first quadrant, we don't do anything. There's no reference angle. It is whatever it is, right? So anywhere between 0 and 90 or between 0 and pi over 2. In quadrant 2, we have the reference angle is 180 minus what our angle is. In quadrant 3, we subtract it from 180, right? So be careful, those two are similar, but the order of subtraction matters, okay? If it was addition, it wouldn't matter. But if I do pi first or the angle first, all right, that'll make a difference, okay? A hint for future reference, our reference angles should never be negative, right? So if you end up with a negative angle, switch your spots, okay? And then if we're in the fourth quadrant, we have to subtract it from 360 or from 2 pi. All right, so 144 degrees. That will put us in the second quadrant, okay, somewhere over here. So to find our reference angle, we're going to do 180 minus 144, and that will get us 36, I believe. 36 degrees would be our reference angle. Let me just double check. Yes, 36. All right, so straightforward, 180 minus 144 gets us 36, right? So if I found the sine, cosine, or tangent of this angle, it would be the same as finding the sine, cosine, tangent of my reference angle. All right, and we saw yesterday, and I put up on the Google Classroom that, where is it? The GeoGebra website, right, where you could have found that out, right? So you go over to 144, or get it as close as possible, and when you find the reference angle, you can see it's there, right? Which is around 36. Okay. So that was number 1. Number 2 is 4 pi over 5. So that one, you might have to calculate and put it into degrees to figure out what quadrant it is in. But one thing you can say to yourself, well, is it going to be in the second, third, or fourth? Is it greater than pi? Am I greater than 1 pi? If I'm greater than 1 pi, then it's either in the third or fourth on the bottom. Okay, but I'm not. It's 4 pi over 5. So again, I'm going to be somewhere over here, right? It'll probably be kind of close to the x-axis, but we'll still be in the second quadrant. So my reference angle, theta prime, will be pi minus 4 pi over 5, right? So we have to find a common denominator. So this would be 5 pi over 5 minus 4 pi over 5, which would get us 1/5 pi, or you can just say pi over 5. Okay, either one of those would be all right. For number 3, we had negative 213 degrees. All right, so I'm not sure if I don't think I went over this, but what we did yesterday, right, was we found a coterminal angle with this. So I added 360. Now, sometimes when you add 360, you might end up here, right? So if you add 360 and you end up with an angle between 0 and 90, then that's your reference angle. That's what you have. All right, so we could do negative 213 plus 360. So that gives us 147. Another way to look at it, I'm not sure if I went over it. When we have a negative angle, a negative degree or negative radian, that means from our initial side, we're going to go in the opposite direction. Right? So if I'm traveling in the opposite direction, this would be negative 90 degrees down here. This would be negative 180 degrees. And then this would be negative 270. So again, that would put me somewhere here. So that's negative 213 degrees if we read it that way. If we find the coterminal angle, we just found that that was 147, which is real close to 144. So our reference angle will be 33 degrees. All right. And then our last one, like I said yesterday, you won't see this too often, but I did want to give you some practice with it. Let me just make sure. Okay, yeah. We have 1.7 radians. All right, so you say to yourself, well, this was pi, which is 3.14. So it's less than this. Okay, this is pi over 2, which we said yesterday was, let's see, pi over 2 would be 1.57. So again, we're going to be in the second quadrant, right? So my rule is for the reference angle, we do pi minus our angle, 1.7. So we can do pi minus 1.7. And we're going to round that, and we're going to say about 1 point. You could say 1.4 or 1.44. I'll give it 2 decimal places. All right, and I'm going to say radians at the end just to make sure we know it is not degrees. All right, any questions about the assignment from yesterday? All right. So before we begin with the lesson, I do want to just make a quick announcement. I don't know if you've noticed. Just earlier in the day, I put up 2 worksheets. All right. They will be extra credit for the second marking period, and that is due Friday. So if you'd like a few extra points added. Now, I haven't finished grading yet. Hopefully, I have a meeting later today, but we'll see how the meeting goes. Maybe I'll do some work during the meeting. But I should have the grades completed for the second marking period later today. So if you like a few extra points after I plug everything in, then you can do the worksheet. We're going to treat it like we did last time. I'm not assigning any certain amount. If you only want a few points, only do a few problems. The more you do, the more points can go to you. All right, so there's the 2 worksheets. One of them is on, I forget what's on. Let me look. One of them's on exponential and logarithm, and the other one's about rational functions. So finding asymptotes and things like that. All right, so you have those as extra credit. Okay. Let's see, where do I want to start? So we did reference angles. All right, so today we'll wrap up with the reference angles and how to use them. and we'll use them in evaluating trig functions. All right, so we'll start by doing 4 pi over 3. All right, we want to find the cosine of 4 pi over 3. So there's a few things that we can do. Well, one, we want to find the reference angle. Right, that'll help us find the angle quicker. Right, so say we don't have, a calculator. The second thing we want to do is we want to reference this to see if we're going to be positive or negative. Right, so we're doing cosine of 4 pi over 3. Now, 4 pi over 3 would lie in the third quadrant. Right, so because I'm finding the cosine, when I get my answer, I'm going to make sure that that answer is negative. Right, because anytime we take the cosine of an angle in the third quadrant, it's going to be negative. That's a rule. Right, so my angle is 4 pi over 3. So we want to find the reference angle. Right, so because we're in the third quadrant, I'm going to do 4 pi over 3 minus pi. Right, I'm just going to put Q3 there just so we know it's in quadrant 3. So to find the reference angle, we subtract. I'm going to make this 3 over 3. So my reference angle is going to be 1 pi over 3. Right? So what I can do now is I can rewrite it that the cosine of 4 pi over 3 is going to be negative cosine of pi over 3. Again, this negative is here because cosine is negative in the third quadrant. All right, so originally we didn't have the negative in front, so we have to add that there to remind us that we need to do it. Now, the cosine of pi over 3, I don't know if you remember, but that does appear on our unit circle, right, or our special right triangle. Okay, pi over 3 as degrees would be 60 degrees. Right, so we have the cosine of 60 is 1/2. So we're going to have negative 1/2. And there we go. All right. Now, again, you could use the unit circle, right? 4 pi over 3, you could probably find it there. But this is just a quick way to determine. All right, let's do one more before we get into some hardware stuff, because this is I feel this is pretty straightforward. If you have questions after this, we'll address those. Let's find the tangent of negative 210 degrees. All right, so anytime we deal with a negative degree or radian, right, we want to make sure it's positive. So we're going to do negative 210 plus 360 in order to get the coterminal angle. And in doing that, we get 150 degrees. Okay, that is quadrant 2. So you go back to your chart. Quadrant 2, if I'm doing tangent, tangent is negative. Right? So tangent of negative 210 is going to be negative tangent. Well, now I want to find my reference angle. So my rule with 150 is we're going to do 180 minus 150. So my reference angle is 30 degrees. So tangent of negative 210 is the same as negative tangent of 30. Right? Again, we have our unit circle, or we can use this. Okay, tangent of 30 . Oh, I put these in the wrong spot. This is the 1, this is the root 3. Tangent of 30 is 1 over root 3. So we're going to make that negative 1 over root 3. But again, we don't like that square root in the bottom. So we're going to say negative root 3 over 3. All right, any questions so far? Would you like to do one more, or would you like to move on? All right, so moving on, since I've heard no qualms, we may be asked to combine everything. So we could also use our trig identities that we learned to help us solve problems. So this would be an example that you might see. It's a little more in-depth. Let's do a two-parter here. Okay. So here they tell us that we have an angle, theta, but they don't tell us what that angle is. Okay. They tell us some information about it. It's in quadrant 2. And the sine of our angle is 1/3. So we're going to use that to find the cosine and the tangent. Right? So, you know what? Before we continue, this is a quick way to memorize the chart that I gave you before. And I forgot to mention this. Right? So here's our quadrants with what's positive and negative. This here is a quick way to tell what's positive. All right. So up here, all is positive. So sine, cosine, and tangent is positive. In this quadrant, sine is positive. In this quadrant, tangent is positive. In this quadrant, cosine is positive. All right. And that means if you don't see a letter there, everything else is negative. So here we have our angle in quadrant 2, and the sine is positive. Right. So that makes sense because we're here. So moving forward, our cosine and our tangent, we should have negative numbers, right? So again, if you end up with a positive value, you have to go back and fix something. All right. So for this first one, there's a few ways we can go about this. I can make a triangle, right? So here I have the sine of my angle is 1/3. So I'm just going to set up a triangle. I'm going to put my angle anywhere. And sine is opposite over hypotenuse. So this is telling me my opposite is 1 and my hypotenuse is 3. Now I can use Pythagorean theorem to find this side and do the rest. Right? But we're not going to end up with a nice number. We're going to end up with some square root. So let's see if there's another way that we can do this. So going back to my identities, I want to find a way that I can relate sine and cosine directly. I know that the tangent is sine over cosine, so I can use that rule for tangent, but that's not going to help me find cosine. Okay, I don't have enough information to find cosine with this. So there's another piece of information that we learned, okay, and that was one of our Pythagorean identities. We know that sine squared plus cosine squared is going to equal 1. Well, they gave us the value for sine squared. It's 1/3. So I'm going to substitute that. So I have 1/3 squared plus cosine squared equals 1. I'll get rid of this for now. We'll come back to that if we need it, but I don't think we're going to. All right, so here I can square 1/3. Right, we have to make sure we square the numerator and the denominator. So 1 squared is 1. 3 squared is 9. So I have 1/9 equals cosine squared of 1. And now we treat this like a normal algebra problem. I'm going to subtract 1/9 from both sides. Okay, 1 minus 1/9 gives me 8/9. I want to find cosine. This is cosine squared. How do we normally get rid of a squared? We throw up a square root. Right, that's going to cancel this out. So here I have cosine. Now, just like the squared, we distributed that to numerator and denominator. We're going to distribute the square root to both. So I have the square root of 8 over the square root of 9. Well, the square root of 9 is 3. Right, and now I just want to simplify this. So I know that the square root of 8 is the same thing as the square root of 4 times the square root of 2. The square root of 4 is 2. So my cosine, I can say, is 2 times root 2 over 3. Right, because we broke this up. If you give me that answer, you're not going to be wrong. Okay, I'll just tell you that you can take it further and you can simplify. Right? So we have the cosine is 2 root 2 over 3. And again, we like to keep it like this. We don't want to round if we don't have to. Keep it simple. Now we can find tangent because we have sine and cosine. Sine is 1/3. Cosine is 2 root 2 over 3. Let me fix that. All right, so here we're dividing fractions. So we're going to, oh, I forgot. Always got to have the theta there. We're going to do keep, change, flip. So I have 1/3 times 3 over 2 root 2, right? We take the reciprocal of this, we swap the numerator and denominator. Well, this is nice. Those eliminate each other. All right, so we have 1 over 2 root 2. Now, there's one thing that we forgot for actually both of these. We are in the second quadrant, so I have to make sure that the cosine is negative and that this is negative. All right, we just want to make this look a little nicer. So I'm going to multiply the top and bottom by the square root of 2. All right, so down here, this is going to give me 2 times 2, which is 4. I'm running out of room. I'll put it up here, 4. And in the top, I have the square root of 2. And it's going to be negative because the tangent is in the second quadrant. All right, so we found both the cosine and tangent without technically doing any, actual trigonometry. We just used the identities, the rules of trigonometry. All right. Any questions?